what is shown here is an 8-bit multiplier with a 16-bit output. Now of course you can change the number of bits in the output to a lower number by moving what is here on the left, doing the circuit in a way that looks like this, just moving it to the right and basically doing it in a perfect straight line. For example here, to get an 8-bit output, then you're basically just truncating the result to 8 bits. But this one is a 16-bit. This one has a 16-bit output, and of course it cannot be anything higher than that because it only has 8 bits of input for both values. Right, so I will now demonstrate the multiplier working. I will do as a demonstration 5 times 5, and here translating this output to decimal is 16 plus 8, that is 24, plus 1 is 25, and the result from 5 times 5 is indeed 25, so that is the correct result. I will also demonstrate what it looks like to turn on all of the inputs. So that is in hexadecimal FF times FF, and the correct result should be 7 zeros followed by 7 ones followed by 8 zeros followed by 1 1, and that is indeed what we see here. This is the highest possible number that can be outputted from this circuit. It cannot be anything higher, that's the highest value. Right. And then now I will take a closer look at the circuit and explain the functionality after I've turned off these inputs. Now, as you can see here, the way this multiplier works is that it basically has a series of full adders, the input of which is always the result from the previous full adder, and the other input being a bit shifted version of the input here. And the bit shifting always moves one step to the left for each of the steps of the bits, the number of bits. So I will turn on the first bit here to demonstrate the effect. As you can see here, the bit is always bit shifted to the left. As you can see here, it moves to the left. And then you can see that these outputs here that are already finished, they are no longer dealing with the rest of the circuit. That is because the lowest bits are of course not influenced by multiplying with the higher bits. Right, so that is of course the correct behavior. Now I will also show some of these other values. Let's just turn on those, for example. You can see how they get allowed through. Now I will now show something interesting. Further demonstrate some of different numbers. What happens if I pass these through? I'm not going to explain the numbers, I'm just gonna show what this looks like. As you can see, I'm basically just passing through the value that is set here, bit shifted to the left as many times as there are these, as many as this one is, that many times. Bit shifted to the left, bit shifted to the left. So you can see here this is the third bit from the right, and here it has been bit shifted to the left, so that it's now the 1, 2, 3, 4, 5, 6, 7th bit. So as you can see, it has been bit shifted to the left. And that is what multiplying is after all. It's just adding the same value bit shifted n times to the output. That is what is being done here. That is a multiplier. Right. Then I will zoom in to some of these circuits to show you how they look. You can see here very close look at the circuit. The circuits are basically identical, these cells, if you want to call them those, if you want to call them that, cells. They are basically identical other than the ones at the very edges. So each edge has different types of cells, but the cells are only modified versions of this base. This is like the base design, as you can see here. the ones on the edges are basically just the same as the ones in the middle, but just some of the logic is being removed that is no longer necessary, such as here, for example. Take a look at the one on the left and the one in the middle here. The only difference is that the one in the middle here doesn't have some of these circuits that the one on the left has, because they are redundant here. So the ones on the edges are different slightly because they just remove those ones that are not necessary. That applies to all of the edges, including here at the top, as well as here at the very bottom. The bottom is also slightly different for the way it handles the inputs as well. It actually has inputs like this. This design can of course be extended up to infinity, because all that it has is just the same replicating design. Basically, it's just, you can basically just extend it. As you can see the way it's designed. Here's a full picture of the design. You can basically just keep replicating it, extending it. Those points at which it terminates, how wide it is, the dimensions, they can be adjusted. Of course, you can add more inputs, and of course with that you can increase or decrease the number of bits at the output within the range that the output can be. Right, so that's the design. And I don't think there's anything more to this video. That's it for this. Thanks for watching. Until next time, bye.